And here we are again. Stream-o-matic. Actually, hey Garcia, how you doing? Forza. Got two cameras. I try out a new camera, and you can see my setup here. I'm on my kneeling chair at the moment, so that makes me look rather weird from this angle. And yeah, Acorn System 1. This, I haven't got this in. it's lit up. Right. I suppose one good thing about having the camera there is when I'm looking at the chat, which I see up on this monitor, I'm looking at the camera, the top one. Is my... How do you mean? What's wrong with the microphone? It's the wrong microphone. Thanks. I had to figure stuff out. Main mic.
Hello? Main mic. Hello? Is that better? I think that's probably better now. Yes. Okay, cool. I'm about to hit play on this thing. I was just tell me how loud this is. Was that all right? Could that do with being louder or quieter? I think it could do with being a little quieter, actually. So, what am I doing at the moment? I think I turned it down now. Maybe a bit more. It's a tricky thing because it doesn't look loud. It doesn't look loud on the meter here, but because it's a single tone, we perceive it as loud. Hopefully that's all right. Will you let me know? And this up here on the top, this is the Acorn System 1 cassette interface. Data, and I'm writing a program to decode it. And this is analyzing everything up until we get the first... Well, I think, yeah, that's true, actually. If any of these numbers, 4 or 5, it means it's it's these bits which are zeros. Or are they ones? Ones, actually. It's always 1. And I think I probably can... There. So I suppose what I should do is make a little state machine for deciphering this thing. Did I do a thing called skip? Am I using it? No, I'm going to put a thing here called state. And then those are the numbers that I'm printing out here. I'm going to take that out a minute and do that. Put the switch statement here. Switch state case 0. Now, in a case of 0, that would be the first state. It means we are searching. Now, when I'm doing this kind of code, I know that there are various criticisms people will make. I mean, one of them is like, why am I using just numbers in a switch statement instead of setting up enums? I'll tell you why. Because if I have to set up an enum, I have to go from this piece of code to some other code. I have to put it up here, and I'm splitting my attention between this code and the thing I have somewhere else. And that is one of the problems with with it. I mean, you know, if you're using a programming language where you can use strings for everything, this isn't a problem. But here, I really don't want to have to slow myself down and name the states. So what I find is it's for prototyping code at least, not production code. I mean, and let's face it, this isn't code, this is, and it doesn't take long to do that. If you want to refactor, you do it. But while I'm building it up, I don't want to split my attention between here and somewhere else unnecessarily. So I tend to just use numbers, and they'll write it down in a comment what the thing is. So in this case, it's we call this, it's looking for the leader, and if the length is greater than or equal, greater than 7, then what we found is the first 0, the start of the first 0. And so I guess we'll set the state to 1 at this point, and then you do case 1, and at this point it's we were looking for a start bit. Or we can do leader or search for start bit, and the tape would have to be moving very very quickly for it to be longer than 7 centimeters, because this is all written on tape that's moving at 1 3/4 inches per second. I mean, you'd probably be supersonic tape for it to be 7 centimeters. So no, it's not 7 centimeters. It's 7 samples. Because I'm sampling at maybe 24, wasn't I? Yeah, 24,000 samples a second. Hi, Zag. Oh, I suppose we should have our themes. Well, Garcia was first. Hal, play Garcia theme.
Hello, Dino.
Panel. This is it. Then we go to recording. Microsoft making user interfaces, taking user interfaces where they've never gone before, and double click on microphone and click on levels, and let's pull this down to something like 15. Hello, Hal. Oh, come on, you can do it. You know you want to. Hello, Hal. Look at this, there's a lot of noise on this microphone. Did it get reverted? It probably did, because this is also fairly normal. You do this and then you have to do it again. Sound control panel, and wait for this to, yes, it. And then you recording and microphone. This is the one that Hal uses, and we get on levels, and it's 15. What is wrong with it? Maybe I'm using the wrong one. So what we'll do is we'll go back to, because I've messed about with all my audio settings. Dialog box, please. Thank you. Audio. Microphone USB 4. Microphone USB 4. Audio recording. Hello? Okay. All right, look at that. What is going on there? It's so... Hello? That's why it's not working. It's because there's all this noise on there. Where's this noise coming from? Oh, might be the Acorn Atom. Acorn System 1. Are we... How is this now? No, that is very... Ah, gosh, that was always a flipping problem with this thing. Why is it doing that? Yeah, I was changing the level. I don't think the level worked. I don't know. Maybe Hal is mute. No, I don't know. I don't know. Hang on. Sound settings. Sound control panel. Recording. Double click microphone twice because the first double click didn't work. Go into levels. It's back to 53 again. Let's set it to 10. Okay, okay. Hello. Hello? Are we better now? Oh, it looks like it. Hello, Hal.
Hello, Dino.
Okay, and I can't hear him because he's muted here. It's all very complicated. Jeez. Hello, Hal. Oh. Hello, Hal. I don't believe this. Hello, Hal. Hello, Hal. Open sound settings. Sound control. Sounds. Recording. Microphone. Levels 30. Hello, Hal. Hello, Hal. Hello? What is up with you? Oh. I'm going to try him in a different position. Put his ear. Hello, Hal.
Hello, Dino.
Well, let's see if that's better. A little microphone placement and so on. I mean, it's 2021, you know. I can't expect everything. Right, where was I? Hal, play Garcia theme. What happened there? How? Why did you stop? It was going so well. Oh, Hal heard your theme and and thought it said HAL silence, and so it stopped it. Oh my word. HAL, play Garcia theme. HAL, play Zag theme. I can't actually concentrate when those themes are on. So, there we are. Ding, 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 ding. Concentrate. Looking for the end of the start bit. So basically, what all this is doing is it checks how long these pulses stay high for, and these are all about 4 or 5 samples, and then it gets bigger here. So what I'm going to do now is search for the first point where there are not long samples anymore. So yeah, so if length is less than 8. Well, let's do less than 7, then there's a little bit of hysteresis. The refurbished, well, not refurbished, just repossessed, dispossessed. And so, at this point, when the length is less than 7, it means I've reached the end of the start bit. So then, let's check how many samples for the start bit. So this, right, okay. Bit start equals 0. So when I had the bit start equals the current sample count. So in this way, I know where the bit started. So the length is going to equal sample count minus bit start. I'm going to start at some point. I'll start adding a capital S there and get annoyed. Right, bit start. So bit start equals sample count, and then here I can get the length. Now, how many cycles is it supposed to be? I don't know. Let's print it instead of trying to. It's actually better to just print it. I mean, I could work it out in my head, and then I would need to go and do this anyway to test it, so might as well just. But actually, let's just do a %d length, %60, %60, sample count length. So, right, sample count length. Right, and now if I run this, and you know what, just because I'm just going to make it exit at that point, it's just easier than scrolling through tons of text. And there it is. So we can see that it got to sample 60,064 and then found that bit. And at 20,000 samples, 24,000 samples a second, that's only a few seconds. That's only a few seconds. And so, that seems reasonable. And we can see that the start bit lasted 150 samples. And if we divide 150 samples by (150 samples divided by 24,000 samples per second, where is the inverse on this thing? Oh, there. 160 cycle. That's all. Oh. Hang on, I'm doing my maths wrong. It's 150 samples. And there are 24,000 samples per second. Okay, that's about 6.25 milliseconds. Now, this should be because there are 2 0 bits here. The start bit. Oh, right. Yes. Okay. Right. The start bit does 4 cycles at 120. Right. Yep, so I need to calculate this in a different way. It's 4 cycles multiplied. This calculator's really annoying. 24,000 samples. No. 1,200 cycles a second. It's this amount of time every second, every cycle. And I need to multiply that by 4. So that's how long it should last. That's about, yeah, it was 6 milliseconds. Each one should be 3. Each one should be about 3 milliseconds, but in fact this lasted 6 milliseconds. So it's because it's a start bit, which was a 0 followed by an actual 0. So I can't just check. Well, I can check how many samples for the start bit. I can do that, and then I could see how many bits, or I could check alright, I think what I'll do is I'll also check how many samples on this length until I get to the end of that bit. So that means that if I store that in if I store that in memory, I am sampling the audio at 24,000 cycles per second, or samples per second, sorry. So each 24,000 cycles per second is this amount. If I divide memory recall by that and then do an inversion on it, we end up with 80 samples. So, and in fact I had 150, which is approximately, well, a bit rough, but it's approximately 2 bits. A bit should last 80 samples approximately. The thing that makes it a little trickier is that this is not a precision thing. There needs to be a tolerance built in, and so that kind of programming is always a little bit annoying. What I can say is that if I have gone past 80 samples, if length is greater than 80, then it's like have processed the start bit successfully. Not quite. This was if the length is right, so in fact I have to do it slightly different logic here. If the length is greater than 7, which was what I had up here, if the length is greater than 7, then how many samples for the start bit have we processed? So we got through 80 samples, and so we finished the start bit. The state can move on to 2, and we say yay, we're done. If on the other hand, before we've reached 80, if before we've reached 80 we find that there is a short pulse, it means that we've got to a 1. It means that it arrived unexpectedly early. So what I actually think is I need some tolerance here. So if it's greater than 70, I'll make a... Oh, geez, what button did I hit there? So 80 is the actual boundary. But we're putting a tolerance in there. It needs to get through 70, but I'm getting rid of the edge case by doing that. So, and then it switches to state 2. Now, if on the other hand we get to here, then it comes, we had a bad bit. And then we can print F error at sample %d \n and sample count and exit 1 and see, right, so that compiles. I've got nothing. It didn't print anything. Ah, because it got to state 2 successfully. It successfully got to state 2. And I didn't have a state 2 implemented, so I need to put my default in. I always put a break in there, right? So there we go. And here we do print error unhandled state and then that's it. Now if I run this again, I should get an error unhandled state. Might be nice to print the state actually, %d, there we go. And that's great, because in C++ there isn't a way to print you see, that's the other reason. Is why am I not putting enums in my case labels? Because it all sounds great, but you know what? When you're especially when you're programming in C++, that error message, it would be I could print the number. There is no way in C++, at least unless things have changed recently, there's no really easy way or feasible way of getting it to actually print an enum by value, by name I mean. So the state would come up and it would say, you know, state 73 or whatever, and then you go and have to look it up. So then it's really helpful. So then what you do is you have to write a function to map one to the other just for debugging purposes. I don't really just make them numbers. So this is going to print the state number. Let's try that again. Oh, sorry, did it? Error unhandled state 2 and fine. Case 2. So case 2 is first this is a value bit. So this is getting quite exciting then. It's a value bit. Now what's the point of a value bit? It's the first bit of the value. Now I'm going to have to build the value up. I'm going to go and have here bit count. So the bit count is equal 0, but you know, when I start the bit, because I have a start bit, and here I put bit count equals 0, which is great. because then I know which bit I'm processing. I'm processing the first bit. Actually, this is from the test that I did, the lowest bit. So I'm going to have to shift the bits in as I construct them, shifting right, which means I need to set the topmost bit. So I might do this in a way that will completely annoy those people, the C standard thumping people. They're going to I'm going to do it just to annoy them, really. To be yes. So you've got, it's like, you know, my stream is like a journey through all my hobby horses, isn't it? Yeah. I have the value. Yeah. So if I want to go downwards, I have the value bit. I'm going to build 8 such bits. Normally, I would never use anything other than ints. There's usually not a very good reason to use anything other than ints. But I just want to do some, also because, you know, I'm programming all this stuff for fun, so I'm going to have some fun doing a bit of bit hacking. Right, it's also good for the mind, it's good for the soul. It's not the kind of thing I recommend you do if you want to keep, you know, the people you work with happy. But I'm working by myself, so I can ask myself, is it all right for me to do it? Yes, Dino, just do it, because the purpose of this is for you to find happiness. So caveat here, if you're I have to say it because, I mean, otherwise, you know, people say, and I tried your bit hack and I got fired. Yeah, all right. Well, yeah. If you're followed in the words of Mr. Carlson of Mr. Carlson's Lab on YouTube, I'm a bit of a fan. You know. So if you're following on, you do so at your own risk. Except he always, whenever he says that, you never see him talking. So you never see him goes, he's never going to do that looking at you. That's just the bit that I add out on top. That's my little sort of modification of his. Never mind, Dino, just focus. Right, so what I'm going to do is, well, bit hacking. We could go. I don't know. I'm trying to decide whether to make this an unsigned char or a signed char. You know, it's like. Oh, I really want to do it in a way that abuses 2's complement number system, just to annoy the standard thumpers. See, if you're shifting from the, this is what's going on in my mind, right? If you're shifting right to left, you can just set the bottom bit to the current bit that you're reading in, and then you do a shift. So in this way you keep doing that, but then the first bit becomes the most significant bit, and I need it to be the other way. So what I need to do is feed them in not from the least significant bit but from the most significant bit. So then there's the point of how to set the most significant bit. Well, you can do it by an if statement. If the bit is set, then set the top bit. And that's kind of, yeah, all right. But I was thinking I suppose it's not really that much different. if I'm shifting it upwards, it's just that shifting it upwards, you know what the value is. The value is 1. When you're shifting the other way, the value is for a byte is 80, and 80 in hex. 80 is it feels like a very arbitrary number. Do you know what I mean? It's like, it's one of those little annoyances when I'm doing this type of thing, and I've always, because of course I started off programming in assembler. In assembler it's really elegant. All you do is you set the carry bit. So you would set the carry bit or to either true or false, 1 or 0, depending on the bit that you're feeding in. Then it exists in the carry flag outside of your byte in your register, or your, whatever word, whatever in your register is there. And then you execute the command shift right with carry. And what that does is it shifts the carry bit into the most significant bit of the register. And so there you go. And then, if you want to go the other way, you set the carry flag and you shift the other way. And it's all very logical. There's the bit in, it goes shift. You put it in the carry flag, you shift them in. And of course it's designed that way so that you can chain these together. So if you wanted to sort of shift a whole bunch of bits across a number of bytes, even on an 8-bit processor, you use the carry flag. So you do the shift, and the bit that comes out of the shift goes into the carry, but also whatever was in the carry gets shifted in at the other end. And so you can just chain together these bytes and get them to all shift along. And so then it's lovely. It's a lovely little thing. It doesn't matter which way you're going. It's a machine that makes sense. And then when you're programming in C, all of that, there are none of these operations are not available. There is no set the carry flag because of the bias in the language towards trying to pretend it's a form of mathematics only. The carry flag is an engineering construct. The carry flag is something to do with an implementation in hardware. Oh, we don't need to know about that. And so you don't get access to the carry flag. Also, there's an argument that that's because the carry flag might not be available on a particular processor. Now, it's a valid argument, especially as the language is very old, goes back like 40 or 50 years. But the reality of it is that the processors to get today all have a carry flag. It's a standard way of doing it because nobody's come up with a better way. And it's just a real shame that there is no. I mean, I'd love it if there was if there was some construct in the language that could express these assembler level things. And of course, you go and talk about it, and someone will come, another hobby horse, someone will come up to you and say, oh, you don't need to worry about that because compilers can optimize better than human beings. But they're missing the point. The point is that there is something that you can express, some things that you can express much more elegantly in machine code than you can express in C. And so whichever way you turn it, you've lost something. With everything gained, there is something lost always. And it's just good to be aware of what you're losing and not just try to dismiss it. Because optimization isn't everything. If you have to, there's a lot of code that has to, especially with drivers and things like that, a lot of code that exists that has to manipulate bits, stuff close to the hardware. You have to do it all the time. And compilers will not optimize everything. I could not give them what I'm doing here and expect them to optimize it. It's just not It's not going to happen. So in practice, does it mean anything? Does it matter? Not really. I mean, but you write the code, you get on with it, and you do the job, and so on. But this is programming for pleasure, and so if I'm programming for pleasure, I ask that question. Is there a more elegant way? It's about being everything that you do being elegant. At least for me, it's kind of like elegance is. And there are different kinds of elegance. Sometimes I've written elegant code that looks very inelegant, but the elegance is in the way the problem was solved. Maybe not represented as elegance in the code per se. And that's why I'm thinking about it. So yes. What can I do? Is there a way? Not a lot, actually, but because I can't access the carry flag, I cannot actually do a rotate instruction or shift instruction. They don't exist. Although you can do the number, take a number and do the double less than or greater than to supposedly do a shift. In the language specification, it's stated not as a shift. Again, it's trying to pretend as though there isn't a microprocessor underneath. So it's not a shift, it's a multiply divide by 2. Which is not the same thing at all. Multiply divide by 2, not the same thing as a shift. And you could actually say, why on earth do they have those instructions? Why do they even exist? Why? I mean, surely the compiler can optimize it out. If you have an integer and you divide it by 2, surely that's an implementation. See, it's interesting. Why? Why do they have that? Yeah, ultimately it exists because the origin of the language was one at a time when compilers really couldn't optimize the code very well, because that would at the very least have required a very long time compiling your code. You have to remember that C originally ran on computers orders of magnitude slower. The compilers ran on machines orders of magnitude slower. And so what that actually is, the great, I'm talking about, the shift operations, these things. What those two operators really are a way of telling the compiler to use microprocessor specific operations if they're available. Now, if they're not available, let's say you write the C program and you ask for a shift, and the processor it runs on doesn't have a shift operation. Then it would have to emulate it by doing a multiply by 2. So you can see where it comes from. And this is all fine until you have negative numbers, because then you have the problem of 1's complement and 2's complement, or whatever number system. And it is often not understood or appreciated that the number systems that we have are just conventions. You have in an 8-bit value 256 different combinations. So you can use those 256 different combinations to represent 256 different things. You can use it to represent 256 characters, in which case you've got an 8-bit ASCII character set. Or you can use it to represent 256 numbers. Those numbers could be 0 to 255. They could also be 1000 to 1255. It's just a matter of convention as to which. Yeah. So at the bit level, how you map them. And so there's the question of how you represent negative numbers. So you can represent negative numbers by, well, there have been two ways. The first way that came out was to just simply reverse all the bits. And so then any 1 became a 0 and a 0 became a 1. And so that would mean that the value of 1 have a -1 of 0. But this was rather inconvenient, because then what is 0? Correction, I talked nonsense there. You would have the number 1 would have the value FF. Is that right? No, wait a minute. No. If you reverse the bits, right, 1 becomes FE on 8 bits, or 254, because you've got 0000001, and you reverse the bits and you end up with 11111110, which is 254. Then that's a little bit awkward, because what does 111111 mean? Or FF in that case. What does FF mean? In fact, FF was -0, because if you took 0 and you negated 0, you would end up with FF. All the bits are set. So then is FF a -0? So then you would have a number system where you have a +0 and a -0. But these are integers. This isn't floating point. We're not doing calculus here. What gives? And so the ingenious solution to this was the 2's complement number system, where you flip the bits and you add 1. So if I do that with 0, 1 in hex, I reverse all the bits, I get FE in hex. I add 1, I've got FF. And FF is 1 less than 0. And if you subtract 1 away from 0, you end up with FF. And if I add 1 to FF, which is -1, I get FF plus 1, it clocks the thing over, I get 0. -1 plus 1 equals 0. It just works. And so I don't think there has been a new computer come out with 1's complement number system for decades. But unfortunately, because there wasn't a standard for how to represent negative numbers, this has affected the design of the language to the point where the standard Bible thing, you know, the standards of the language do not define how the behavior of bit operations on signed integers. For that reason, it is not covered by the standard, simply because as soon as you introduce negative numbers, nobody can be sure what they are, except we can in practice. I find I find that story quite interesting. But anyway, so what I want to do is to I'm just trying to think of the most elegant way, once and for all, of setting the top bit without using an if statement. There are a few ways, but is there a way that can be done sort of mathematically? I mean, the first thing I'm going to be doing, but what about the decision about whether to make this signed or not? That was the point. If I make it signed, then there is a potential trick. That can be done, because oh right, actually it doesn't help. I was thinking of something else. You see, if you have a signed number and you shift it to the right, then and it's a negative number, and you're using the 2's complement number system, and you want it to represent a divide or multiply by 2, it's very, so I could go on all day about this, but it's like you need to use an arithmetic shift instruction. So in fact, the processors would tend to have logical shifts and arithmetic shifts. Now the logical shift would generally be relevant when shifting to the right, in other words effectively dividing by 2. Usually the shift left, which is multiplying by 2, is unaffected. Not true. Correction. Well, maybe. Oh. Actually, I think it affects both. Yeah. It does. Yes, it does. It does. Actually, it affects both. I don't know why. It's a good thing I went over this, because in my mind I had it that in fact it wasn't only relevant in one case, but it's relevant in both. So I'm glad I sorted that out. Yeah, so what's the difference between an arithmetic shift and a logical shift? The logical shift just shifts the bits and doesn't care. The arithmetic shift, it maintains the integrity of the top bit. So if the top bit is set and you shift to the right, thus dividing by 2, and you feed a 0 in to replace whatever bit was there, and it was a negative number, as soon as that 0 goes into the top bit, it becomes a positive number. Because one of the other advantages of knowing whether or not a number is negative or positive in the 2's complement number system is just to look at the top bit. If the top bit is set, it is negative, and if the top bit is clear, it is positive. So clearly it's not going to be a good idea to have it sort of flip between positive and negative as you're dividing it down. So what it does with the arithmetic shift is it makes sure that when you shift right, it fills the top bits with 1 if the top bit was 1. And it fills the top bit with 0 if the top bit was 0, so as not to disturb the sign. When doing an arithmetic shift in the other direction, I believe it needs to maintain the sign so that it doesn't modify the top bit at all when you're doing this shift. And so there you go. You look at your microprocessor and it's got these wonderful operations you have no access to. We've got the logical shift left, the logical shift right, the arithmetic shift left, the arithmetic shift right, and if that wasn't enough, you've also got the roll instructions. Yes, you can feed the bits out of one end back into the other. Those are actually used in encryption and also algorithms that for generating random numbers, believe it or not. Linear congruential something comes to mind. It's basically the algorithms that are used to create pseudo-random numbers. There was one that was used in the Acorn Atom operating system, which was very handy. And it would just cycle through all the numbers on 40 bits. Had 5 bytes in its random number generator. So it would cycle through all the possible combinations of 40 bits, but in a very arbitrary order. It's mind-blowing stuff, to be honest. I don't understand the mathematics behind it or how they discovered it. I don't know. But anyway, the roll instruction, if you roll left, all the bits go left, and the least significant bit gets put back into the most significant bit. And there are 2 variants of that. Not all processors support all of these things, but you've got the ones which is rotate. So you've got rotate left, rotate right, and then rotate left through carry and rotate right through carry. Wow. All of those. You're not allowed to know about them. You're not. Like you're supposed to not be allowed to know about exclusive OR. But that one slipped through. It's funny to think floats weren't used in games on 8 and 16-bit. No, it's true. Kickoff didn't have floats. It didn't have flutes either. It didn't have floats. PlayStation 1 games. PlayStation did not have a floating point processor. Everything was done with fixed point. So, but you know, this is one of those things that I like to go on about this stuff because it's just an example of how removed programmers are today from the hardware, and I don't think that's really a good thing at all. I think it's good to know. It's good to know this stuff. I'm a better programmer for it. But anyway, so I digress. So I think it's in the search for the most elegant way to do this, construct a serial data stream into a value. I'm actually going to go with unsigned. Now, why am I saying, just see what happens when I do unsigned. Because the idea that I had about negative numbers and some trick to feed in the bit at the end, can't really do that in C. I don't think there's any advantage in me. So if I'm going to do bit operations on an unsigned char, then I will be keeping the standard bearers of the C programming language happy, and I did want to annoy them, so that's a bit of a shame, but who knows, it might come back. The unsigned char, why am I putting unsigned in front of char? It's because at least maybe it's changed, but the thing is that even if it has changed and the standard now says that char is always unsigned or always signed, it makes no difference, because then you don't know whether the compiler you're using abides by the standard, which incidentally is another point of failing for the people who wave the book around and saying this is the way it should be, when in reality it doesn't matter what's in the book. What matters is what the compiler that you're currently working on does. But you know, so the point here is that chars are not defined in the standard to be either signed or unsigned. It depends. So I suppose one way is you can use the uint8 data type, which they introduced eventually with uint8_t as a standard. That's ugly, that _t, but hey ho. And in fact, I think I will use that because that's the clearest of all. It's an unsigned 8-bit value. To the microprocessor, they're all the same. But to the compiler, it needs to try and keep track of your intentions in order to make it go. The N64 had a 32-bit FPU. Yeah. The game Star Fox on the Nintendo NES had a floating point unit in the cartridge. That was crazy. Somebody must have made a bundle making and selling the FPUs for that. Imagine that. Anyway, that was Argonaut. Jez wrote a game called Star Glider, which was a great fun game. That was a really good achievement. Wonder what he's up to these days. Anyway, uint8_t. This is the byte. And when I set the bit count to 0, I'll also set the byte value to 0 as well, because I'm clearing all of the bits, just like you have to do this. You have to hold the image of the bits in your mind, right? So I've cleared all the bits, just like in a register. And then I get the first value bit. But is this value bit... Well, here's the point. I did end it early, right? Oh, the problem is I've ended it early, because the thing is I need to know where to start. I'm ending this early, so I can't expect this bit to... You know what I need to do? I need to see what the... value...
Hello, Dino.
Value bit search for start. No, I can't search for anything because this is too... it's the same. I had a 0, I'm looking for a 0. I'm going to continue getting a string of zeros. But if I was looking... But I don't know that I'm looking for a 0. I need to decide whether this... Oh, this is complicated, because I'm looking at the moment is 0, but it could be 1. But it could be that I've... I can't just check. No, I'm going to have to... Oh. I'm going to have to actually count the damn cycles. If I want to be really robust about it, and I do, the most robust way is for me to count the damn cycles. Otherwise I get lost. FMV. It was great. It's where people went to get their music. So at least they got exercise compared to now. Now you don't have to go anywhere to get your music. People buy music by pressing a button. And now music just plays in your ears without a context. It's all a bit of a shame. Because music used to be a big thing. It had a ritual associated with it. You know, when you had to go to a record shop to buy your music, and you would go and buy it, and you'd take it home and you put it on, and it was fun. And it was fun because it wasn't so convenient. It actually made it something special. And now it's like the music just plays in your ear. You don't know who's playing half the time. We listen to music, we don't even know who's performing the music, whether they even performed it, if there was even a human being involved. Albums don't exist anymore because people just listen to random selections of music. There's no celebration, there's no ritual. So that's it. And that's what we do. We're so stupid because we create wonderful things and then we destroy it because we shortcut them out of existence. So that's why people don't understand why there's a big retro scene. They don't understand why. They say, it's nostalgia. No, it's not nostalgia. Well, maybe it is. But it might be. It depends what the definition of nostalgia is. But when I listen to great music from 50 years ago, is that nostalgia? It's funny, with classical music, they never call it nostalgia. Isn't that odd? Classical music. Oh, music for intellectual people. Music that is ordained as being okay for, not the hoi polloi of the population, but people with refined tastes. Of course, classical music in its day was pop music, but I mean, but there we are. And but it's like, but they don't call it nostalgia. Isn't that funny? Or Shakespeare. Oh yes, well I love Shakespeare. Yes. In sooth, I know not why I am so sad. It wearies me. You say it wearies you. But where it come from and what stuff 'tis made, I know not. Yes, it's the only bit of Shakespeare I can recite. I've probably got it wrong as well. Yes, but it's like that.
Hello, Dino.
Nobody dares call it nostalgia. Oh, well, you know what? That's the thing with Shakespeare. It's just nostalgia. I mean, it's not. It just seems ludicrous, doesn't it? So be careful with the nostalgia word. No, I'm going through a phase at the moment where I'm trying to reconnect with the things that I connected with in my younger days. I'm looking for answers to questions such as, what could we have possibly done? How far could we have pushed the technology of then? Did we really explore all the opportunities, or did we just keep jumping from one convenience raft to the next in our journey to everything being somewhat meaningless? And that's the thing, isn't it? Humanity will convenience itself out of existence. So that's what I think. I think it's quite sad that things like FMV don't exist anymore, really. And actually, things have become a lot easier now that for consumers. They're told what to buy. They're shown. People buy into things that they're sure is safe. Maybe that's always been the way. Keeping up with the Joneses is an expression that goes back a long way. Maybe it's always been this way. Maybe it will always be this way. I miss FMV. So there. Meanwhile, back at the ranch, I wanted to avoid discrete counting of the actual cycles, but I can't. I'm really going to have to read the cycles. But it's complicated because I've got samples of the cycles, and the sampling and the cycles do not match up 100%. So there's still a tolerance that I need to do. So let's go back to the beginning. I search for the start bit, and I found the start bit. And then I was searching for the end of the start bit. I can't do that. I'm going to have to actually count the cycles. So that's on the downward zero crossing. So what I'm actually doing is looking here. You see, look at this guy. There's one sample that came underneath. And that's an edge case right there. Look at that. I'm looking at the downwards on the zero cross downwards of each of these. When I have found the first one, extended one here, and it's found, I'll then need to count a certain number more of these. So I'm gonna have to rewrite this. If I go to state 1, it's not search for end of the start bit. It's going to be count there's got to be a better way of doing this. This is ugly. And I'm inside a flipping state machine, a switch statement. Hold the state as I'm parsing this. It's almost like I wish I could use a flipping coroutine. It's the type of programming that is not the easiest in the world. Well, I need to have, you see, because part of the problem is I need to have I want to have a subroutine, right? A function. I want to have a function, but I need to be able to retain all. I'm going to have to, yeah, okay, you know what? I'm going to just have to start yeah, okay. Decode state. I'm going to just do this, then I can pass this around, and then I can actually break my code down, but this means I really need to refactor this. I'm going to just rewrite it, because this was just going to become messier and messier, and let's just take all of this, copy it, delete it, and back up here, and I'll pop it in here. This is a good thing to do. I'm gonna have to get rid of all of the initializations. Well, maybe not. Maybe this version of C++. We'll see. Well, maybe it didn't complain. Right. So what I'm going to do then is I get a bunch of errors. So what was I trying to do here? I'm doing this outer processing, which is looking for zero crossings. And I suppose I could just write a function that finds the next zero crossing. Yeah, that makes sense. So what I'll do is void find next down cross. And that's going to take a decode state. And I might no, can't be constant. I'll take a reference to that and call it DS. So basically this is going to work on the data in here. You know, I'm avoiding object orientation here because that's a bit like that. I mean, I could. Should I avoid it? So it's like I'm inlining it. Yeah, okay, all right, let's do it. So you do find next down cross from, and maybe I need to, I know I'm initializing those up there, but maybe I want to reset this little, I'm having to basically build the little machine, state machine. And I know I already set value. I need to be able to reset it. I suppose I could do that by... There's an easier way of doing that. And that was a reason, in fact, to keep them separate. Class decoder. The class decoder is going to have in it a decode state, which I call state. Right. Reset state equals new. Oh, I was going to do a copy. I was going to copy. I don't need to do that. I can just say decode state. This will generate a decode state on the stack. Sorry, automatic memory. It's going to generate the decode state and just copy it by value over onto this one. Arguable on the efficiency side, but not on the robustness side. That's actually quite good. So I have a way of resetting it, and it will be reset automatically. That's better. Right, next, find next down cross is going to apply. There's the other problem, is that this is a stream coming from standard input. So I need to have the stream in here. So I'm going to have file star I'll call it file handle, f handle, in the constructor of the decoder. In the constructor of the decoder, I am going decoder to pass in a file handle, f handle equal f. Let's pass that in, yeah. So then find the next down cross while we don't have an EOF, because the file could terminate. Let's have a look for, there is a count and 1. Now that was, what was the point of that? Because I'm reading a byte stream and I have to convert 2 pairs of bytes into, right, I need a get sample. Get next sample. So get next sample is going to get 2 bytes. So this will be, let's give a get char C and D. Let's just change the way this works. C, which is actually in here. So what I need to do is do state.c equals get char file handle state.d equals the same. So we get 2 bytes. I take the 2 bytes and then I need to combine them together. That is the expression that combines those 2 to create a sample. Now, sample, where is sample called? And C and D. Okay, so I can see that these two, and probably sample, copy that, right. Those don't really need to be in the state thing. These are local. Pop them there. So I've got myself a sample. And then if that sample is less than 0, because it's signed, but this purpose of this was just get a sample. Oh, right. It should actually be in here. Get next sample. Well, in that case, I don't need that, don't need that. I actually don't need this either. I can just say return like so, and there, get next sample. There's something wrong, which is that I know, is there? Yeah, I need to change the sample count. I don't care about the byte count anymore. That was what this count was. Let me see where else that was used. And there it's hardly used at all. I do not care about it. I am getting rid of that. I don't need it. What I'm interested in is the sample count. Sample count's important. When I have done this, I need to do sample. Oh gosh. State. Sample count plus plus. So incrementing my sample count. So now I know. Well, this is probably going to be slower than if I was to do a hacky version, but anyway, speed's not a problem here. State sample count plus plus. Yes, I've got get next sample. And what we're going to do is it's time to retire this code here. Which I'm going to do with a hash if. There's no, but I want to keep it around because I'm referring to end if in the refactoring. So that's all been taken out. Need to create a new main, int main, and let's you know, just for the sake of sanity, I'll make sure both are binary. Oh, maybe not, because I'm using one for printing debug information, but let me leave that there. Right, so I've got the file thing standard in. What I want to do is I need to create an instance of a decoder. There we are. Created the decoder. Let's fix the errors that inevitably are there. Get char does not take one, so it's actually getch does, not get char. Go again. Get, oh, come on. Seriously? Get C. Yeah, sorry. Getch. Void returning thing, right, because get next sample needs to be returning whatever the type was of this, which is going to be an int 16 signed 16-bit value and no errors. Cool. So we'll start by testing get next sample, for which I created the decoder I really don't need those parentheses, do I? I've got myself a decoder, and then what I will do is no, it's because I need the constructor in there, right? Of course. So it's standard in, like so, and then having called that, this will all be initialized. Everything's great. I'm going to be able to get the next sample, and while, what do I do if it gets to here? Then we have a problem, which was unexpected end of file. Print You know, something will go well is if I didn't have to move my fingers so far to the backspace key. Unexpected. Suppose I should be a touch typist, but if I was a touch typist, I'd probably have RSI by now and not be able to play musical instruments anymore. Unexpected end of file. Oh, geez, typing to shot pieces. Here we go. And exit with an error. Just exit. It's like an assert. It's just, I can't be bothered to mess around right now. So let's just do that. That should be okay. No, what do we have? Syntax error because I was in the middle of doing something here. We need to check to see if we have reached the end of, and if we haven't, then we get the next sample. Int 16t, oh, let's call it s, equals get next, flipping heck. That's why. Dec get next sample. So we get the sample, and then I'm going to do a print f %d \n int s go. Oh, I was saying it doesn't look like it's working, but in fact we have numbers and they seem to have a pattern to them, as if there is an oscillation going on. So that's actually looks good. So I'm able to get the samples, and then I need to get from the samples find the next down cross. I suppose we could say that we've got a sample count, which a byte count, which I'm not really using. And we've got a sample count, but then we have a cycle count. So that's the count for these. It's all on a grid, so we could basically say cycles at this higher frequency of 2,400 cycles per second. So we had a sample count, which I am using. In fact, what am I not using? I just got all of this rubbish here, this stuff here I'm not using, so I'm just do that. I know there's a command for commenting a block of code, but I can never remember what it is. It's just like, I can't be bothered to look it up. And it's thinking time anyway. So errors, what do we have? Sample count is not a member. Right, well, that's fine. We bring that one back to life. That was the only one being used. The other one I want to use then, well, if that's the only one being used, guess what? Well, the rest of you can go bye-bye. The int sample count, The next one would be the cycle count. Also initialized to 0, cycle count of these cycles. So I've got find next sample, I need to now have get next cycle. And basically we could look at it as two kinds of cycles, why not? Either, yeah. I'm a little bit concerned about these little edge cases here. It's not a very clean crossover between them. I mean, is it always that messy? Yeah, it should actually be up, down, 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 up, down. If I look at that one that was dodgy, we can see it here, here as well. This was another dodgy one. Up, down, up, down, up, down, up. Where's the down? Is there somewhere just a single 0? There. This is a single 0. And I've just lost it. This looks like, oh, this is so painful to face here. There, this one, there, zoom in on that. There are 4, up, down, up, down, up, down, up, down. Sometimes that last one gets squashed. You end up with this situation, which is not ideal. So what am I going to look for? I could look for the next down cross. And I keep looking for those. And then I look back and say, how long was this up? So when it comes here, it's going to go, okay, well, you've been there for a good length of time. You are a 0 bit. Now, if we had a case where these two merged in together, which looks like it can happen. So if they merge in together, it's possible this one here is going to be a long one. And then the short ones, the next bit will start and we'll miss a cycle. So I can't just count them straight. I need to be cleverer than that. No, I could. What I can do is I can see if. Oh damn! Why did I hit that? I lost where I was. If it's longer, I can simply say that they've merged together and take that into account. Actually, I don't think it's that problematic. Here's one that's very dodgy. Look at that. But it's going the other way from the short to a long. So in this case, if that was missed, it would go and see one bit. What's going on? Talk, talk, beeps, 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 talk, talk. What's up, Garcia? Is there something wrong with the audio? Oh, right, because I hit play. Yeah, sorry. Hopefully I didn't deafen everyone. Yeah. The beeps. So, okay, so what I'm going to do is look for the next down cross and see how long from the previous. And so it's like from here to here, there's that cycle, and I go from here to here. Let's say if these were to merge, and it would say that's a very long one. It looks like it's a long one and a short one combined. And when that happens, I know that I've gone one bit into the long or the short, depending on which one I am in. So I do need to have a find next down cross. So what this is going to do is get the next sample. I'll get the next sample, and but I also need to know what the previous sample was. I'll put that in there. That's the previous sample. So I've got the next sample and the previous sample. When I get the next sample, how do I set the previous sample? So actually what I'm going to do is not do it that way. I'm going to ensure the integrity of this by having a previous and current sample. So you can have a previous sample, you can have a current sample. So then I can just say get next sample. And get next sample is going to say then right, this became a lot smaller, didn't it? So I'm going to go back to this, get rid of that. Don't need to have that anymore. the reset now. I need to explicitly reset these values. Get rid of this state. Right, so previous sample equals current sample, and current sample equals that. So you get the next sample if current sample is less than 0 and previous sample is greater than or equals 0, then we have a crossover that is downwards. But we're doing a find. And this can just do return. So let's get find next down cross. Down found at sample percent D found at sample count. Guess be sample count -1, but I mean whatever. Right. So this was a test of get next sample. Now what we'll do is just say decoder find next down cross. Don't need that anymore. Let's see, does that compile? Yes. Did it run? What happened? There it is. Unexpected end of file. Right. Because it's just going to keep running through the data until eventually, well, no, it should have found one. So it's time. It means it just carried on. It never found a case where the current sample was less. All right, so let's put a breakpoint there and see what happened. And it never reaches that. Really? So it couldn't find that get next sample. What's wrong here? Aha. Yeah. Break. Return. Actually, it's weird because I've got two characters that I get and it could have the EOF between them. I'm going to just change the way I do this here. So if file EOF that's better. Right, let's try that. Down cross found at sample 1. Really? Well, it's right at the beginning. It's entirely possible. But I need to see the data. So Every time I get a sample, I shall print it. I'll print 3 numbers. %6D, %6D, %6D. 6 characters space for each one, and the current sample, previous sample, sample count, previous sample, current sample. So the first sample was at 0 because it's comparing with the previous. There wasn't a previous. So I'm just going to make a small modification to this. If actually, if current sample is less than or equal to 0 and previous sample is greater than 0, and then that actually caters with that 0 edge case. It found a cross down sample here at sample 7. So that's where it was high and it went to low. This is low to high, and here's all high, and here's high to low, and it found at sample 7 the first down or the next down cross. So okay, that's good. So having found the down, I then need to know how far it was from the previous. So I need to know what we can do is int previous down cross, and we'll do a current down cross. So just going to keep it disciplined here. So current down cross and previous down cross, and follow the same pattern because it will serve me well. In fact, here's fine. The next down cross, like with this, we're going to have the previous down cross equals to the current down cross. It says, okay, sample was found there, so we can say the current down cross equals sample count. And now, because it's automatically remembering where the previous one was, when I find this cross down thing, I can now calculate its length. Length %d sample count. I need to have the previous current sample, current down cross minus previous down cross, and we'll try running that and see what we get. And there we are, sample at sample 7, length 7. Now we know that a length of 7 samples, so if we're looking at this, a length of 7 samples from here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is found this first one was length 7 because it was just the beginning of the recording. So what I need to do is put in an exception here. If previous current samples, blah, 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 blah. And previous down cross is greater than 0, because I'm going to ignore it if I'm going to sample that, format that, it doesn't want to anymore. It's going to ignore this beginning of the recording. Hopefully. Let's see what we have now. It goes further. Oh, jeez. Goes to the end. Right. Yeah, the problem is this line needs to be moved up. I always should set the current cross. This is a question of whether to terminate, whether we actually found it. Yeah, okay, try again. No, it's still, what? Get next sample. All right, this is all very wrong. I just messed up with that. Here I need to do if no, 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 no. Bool first equals previous down cross equals 0. So this is true if the equal previous down cross is equal to 0, and then here we do if not first. Order of execution, right? Oh my gosh, come on. That doesn't work either. What am I missing? If the previous down cross is 0, oh. Yeah. The problem is it goes through this list and it's going, that's a little bit ugly. I think I may have, oh no, you're right, thank you. It found a down cross at sample, I found at a sample 16 of length 16. Now 16 samples, that's quite a lot of samples. So, and here we go, right, where are we? Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That's okay. Well, what's 16 then? Short one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's sort of like halfway between the two. So to look here, the first down is that one. And this is the second down. Well, it's positive here and it's negative here. And it's not 16, it's length. Yeah, the current. Yeah, there's a bug, another bug in that code. Flipping heck. Because. Yeah, I'm not doing this. Oh. Yeah. Yeah, there's another bug in that. This is. That's better. So down cross found at sample 16, length 9. That's better. So if it's a length 9, it's short. And that's what I'll be expecting. They're all short ones. It goes between 9 and approximately 10 and 20, I suppose, samples. So having found the next down, I'm able to see from the gap between them whether it's a short cycle or a long cycle. So find the next down. Right, so what do I do next? Going to have to the next thing. Right, so the next one is to find. It's a function that is going to be called find next zero cycle. No, a zero cycle. Find next long cycle, let's call it that. So this is the first thing it needs to do on the leader, is to find the end of the leader where the first one of these long ones come. And so for that I need to do, let's just do a for loop again, for. And this should be easy because all I'm doing is find next down cross, and then if current down cross minus previous down cross is less than threshold. Now threshold is going to be static const threshold equals, say, 15. Should be good enough. Because it was, well, let's just count them again. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for a short one, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I miscounted. Oh, this is a short one because of the aforementioned problem. I need to count a full cycle. If I count the full cycle, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So 15 is a good threshold. So if the length basically is greater than the threshold, then we've found it. And what we need to do is set then a start. We found the start of a byte. And so what it will do is say what did I call it? Flipping heck, I've forgotten already. Byte start. So byte start is going to equal sample count. So then I know sample count minus length equals length is greater than minus length. So the byte start equals, so that's the beginning of the byte. We can print a statement here, print f, byte starts at %d \n. One of my problems is I use two different keyboards, and one of them is English and the other's American. Byte starts at %d byte start, which doesn't appear for some reason. Oh, you flipping pain. It's because I forgot to add it. It's like, that's why I prefer Emacs's autocomplete. It doesn't argue. I mean, why is it arguing with me? It goes and replaces it with its best guess of what I mean, when in fact what I mean is that I forgot. And that's another thing. It's like, this affects the way when you're using these tools, it forces you to put the variable definition in first, always, because you rely on the autocomplete. So you're always breaking up your thinking. I mean, there's nothing wrong in working the other way. You create the variable, you use the variable first, then you define it. Why not? If you want to do it that way, do it that way. But everybody is forced into doing the other way because they rely on the autocomplete. I don't think that's healthy. Const, it should be a const int. I've got a syntax error here, missing semicolon. And okay, let's try this again. What have we got now? Hello? I haven't called find long cycle, so let's just call that. So I went through it and it found a down cross at sample 16 length 9, and then finding all these which are short. At a certain point, it hit the end of file, so it never found it. Seriously? There's a 20. It should have at least stopped there. Oh. Let's try that again. Byte starts 59,000 cycles in. Just a few seconds. So it's found the start. Okay, fine. And this will be a start bit. So what I need to do now is skip. Oh, it's quite easy now, I think. Skip bit. Now, what a skip bit does it puts the sample count at the next sample that it will read at the end of the current byte, which we know from byte start. Sample count. No, but I can't do that because it's not so simple, because I'm reading a stream. I can't just jump around. So what I need to do is keep finding down crosses until keep crosses until the appropriate time for a single bit has elapsed. That's basically what I'm going to do. So for this, let's just do an infinite loop again. I like doing it this way because then I don't need to think about it. I can put the break anywhere in the loop. So the first thing I want to do is find well, actually, having said that, I'm going to change my mind because I want to check at the beginning. So probably more robust. So what I'll do is I see how far away are we from the start of the byte. Well, the start of the byte. That's the sample count minus the byte start. While this is less than, and I need to put a number in here, which is going to be the number of samples in a complete bit. And we already ascertained that there are 20, and that's correct, it would be 20. The frequency of the sampling is 10 times, 20 times the frequency. Right, it's going to be 20. It is 20. Right, so what I'm going to do is put on here static const int bit time equals 20, or bit samples equals 20. So what's going to happen there is that, having got my bit samples, I can go in here and say bit samples. So if the sample count is less than the bit samples, or while it is less than the bit samples, we're still in the same bit. And this is from the start of the byte, which was calculated correctly up there. And taking into account that when I've detected the byte, I've actually moved on from the byte. So I subtract the length of the beginning of the byte away from the current position, because I'm some way into the byte already, sorry. But I want to skip the bit. So we have a bit start and a byte start. So let's do a bit start and a byte start. I'm gonna do both. So it starts getting complicated, doesn't it? It's deceptively tricky. Byte start, bit start. So we can go into here and do a bit start. When I find the next cycle, I've reset the start of a byte and also the start of a bit. I'm skipping the bit here, not the byte. So what we need to do is keep finding the down crosses until we've... So not byte start, that'll screw things up. There's bit start. While that is that, find the next down cross. Next down cross, please. So this keeps finding the next down cross until we get to the end of the first. So this way we have skipped the start bit. And looking at the way this goes, the start bit should then be followed by the first bit, which in this case is a 0. So we should have passed to this point. It'll get faster in a minute. So we skip the bit, and we're just going to set this up here. So decode, we're going to skip bit. This is skip the start bit. Okay. And then finally we need to look at our first piece of actual data, which is the bit that follows. So we need to read a bit. Read bit. Now, and then this is going to return a boolean, because the bit is either true, it's true or false. How do we read a bit? Well, what we need to do is check the assumption. What's the assumption? Assuming we are at the start of a bit, it's going to read that bit. And the way that we do that is we find the next down cross, and I can get some error correction into this because I'm probably not going to need it, but obviously there are a few bits to check, and they should all agree on. It's like there, a 1 bit has 8 cycles, and a 0 bit has 4 cycles in it. But I'm just going to start right now by reading the first one, and the first assessing the size of the first sample. I mean, as having said that, I could just, well, yeah, okay. Let's do this slowly and do this. Look at the first one. Fight the next round. For now, just check the first cycle length. It should be absolutely fine because I mean this is not like dealing with cassette tape anymore. For now, just check the first cycle length. Okay, so that will be the previous and the current. So we take the length and return that length as being which way round? The bit is true if the length is less than the threshold, and so that should read a bit. Bool. Where's B? B. Bool B equals read bit, and we should finally read a bit. Print F percent D / N bit B question mark 0 1. Oh, read bit identifier not found. Yes, that's better, right? And then off we go. So it does all of this stuff, and at the end it goes and says bit 1. Oh damn, the bit is not 1. It's because I got them the wrong way around. It's actually true and then false. Right, let's try that again. The bit is 0. Very nice. Now I'm going to just print, get rid of the printing of every sample because that's really slowing this down. There we go. And also the down cross. Debug log. Byte starts at 59114 and it found a bit 0. So that I read a bit. And what I need to do though is I do that and then I must skip the bit which I already have code for, and that will skip a bit whether or not it's 0 or 1. So I'm getting closer here. Let's try reading a second bit. I read a bit, I read another bit. So it's going to try to read 2 bits. I'm expecting this next bit to be a 1. Tragedy. What went wrong? Find the next down cross. Keep doing it until we've got the samples and length. Well, let's just use the debugger now. So I'm in here, read bit. There it is, reach the end. The length that was found was 19, so that's definitely looks like it's a 0 bit. Then I tried to skip the bit. Oh. Oh, right, because I haven't reset something. I need to reset the bit. I'm not moving the bit on. When I say skip bit. Is there any other places I need to do that? See, when I find the next long cycle, it immediately says, yes, the bit starts and the byte starts. So that's okay. Then every time I skip a bit, I have to move it along by skipping bits. Yeah, that's right. So when I found one, which I'm here, then I need to do bit start equals sample count. Then that means that I find, yeah, that's right, I have to move that on. Yeah, I'm not sure if that's entirely that's correct, but I'm not sure if that's entirely the explanation for the problem. Yeah, it's still 0. So I need to put the I need to print the samples back. Put the samples back. Byte starts at 59914. Oh, right. Something's not quite correct in what I'm doing, because I find the next long cycle, I skip a bit. Yeah. Yeah, it's assuming we're at the start of the bit. Let's just do a debug log here. So at this point, it says we're at the start of a bit, and it's true, there was a crossing. Then we skip the bit. So in the measurement of the, yeah, what I can do is in here is %D, 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 length between current and previous. There. And said there were 19 between 59953 and 59934. Yeah, so that one is funny because it says the current. Oh, yeah, right. Then it does a skip bit. I can see that it skips. That didn't skip a bit. That's nowhere near enough. Surely. Oh. All right. Positive or negative? It looks like it only saw one cycle, so I think that's wrong. Bit samples is not 20. The bit is multiple samples. Oh, sorry, that's number is wrong, that's why. A bit is I have to count all of these. So let's see, from 1, 2, 3, 4, 5, 6, 7, 8. That was a truncated one, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69. Really? It must be... It's 80. I think what I did was... yeah. It's 80 samples. I was doing one cycle instead of... So it was still in the same... bit 1. Whoa! This is looking promising. I found a bit 0 and a bit 1. So start bit, which it skipped, a 0 bit, a 1 bit, and then we should start seeing more bits. So what I'm going to do is add... Eventually we get there. I'm going to just put this test code here, that, and then we read the bit, we print the bit. Until eventually it dies. Because unexpected end of file, but I don't care. I've got a spit stream. We had a 0, then a 1, then how many zeros? 0, 1. Well, this is the stop bit. So eventually there should be another 1, and there it is. Question is how many bits? 1, 2, 3, 4, 5. Oh. Why did it start with... wait a minute. This is a header. This is the header information, which means that it's not the what I encoded. This is the first bit. 1 bit, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. That's bad. I've lost a bit. Well, okay, but you know, it's seeing some stop bits, and look, there is data there, but the data is not. I don't think it's entirely correct. See, 0, 1, 0, 0, 3, 4, 5, 6. So it's 0, 1, and then 6 zeros. 1, 2, 3, 4. Yeah, it's definitely missed. It's definitely lost a bit. Because there's 10 bits in total. My first bit is a 0 bit. Then there are 8 actual data bits, and then it ends on the Ends on the end bit. I don't know. Yeah, where did that bit go? Start bit as a 0, end bit as a 1. I suppose that I can just print out the full thing again and just go through it. What else can I do? I need to take a break. So how does this thing? Oh, that's not good. Oh, wait a minute. Oh, there we are. So while I take a break, let's find a video. Oh, I've just seen how many people are watching. I never like to see how many people are watching. Basically, it's 2 people. Basically, it's you, Garcia, and Zag. I imagine. It's always best not to look at how many people are watching. La 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 la. Best not to know. Do 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 do. Improvised blues. No, maybe not. Well, I might end this one early because it's 12 minutes long. But I got a copyright. I had a copyright strike for this one. They claimed that this tune belonged to someone else. It was an improvised blues. That's quite funny. Back shortly.
Got myself something to say. Sometimes I feel like want everyone to go away. I've lived my life long time, the same troubles, well, they're here to stay. Spent a long time thinking there should be something more I could do. Spent a long time thinking at least one more thing I could do. Only thing I know, the troubles they just start anew. I woke up and I thought to myself, here comes another day. Woke up and I thought, now here comes another day. Now life seems to tell me a million ways I can play. Trying to say something
Hello, Dino.
I'm afraid to do. Gotta explain something so that I don't know what to do. This spinning world makes me sad. Maybe I should not be in watching the news. While I carry the world on my shoulder, sometimes I carry me. Sometimes I carry the world on my shoulder, and sometimes I carry me. Must be an arrogant son of a bitch. Think I could ever be free. Now I'm not sure what the point of this. I'm not sure what I'm trying to say. I'm not sure of the point. Not sure what I'm trying to say. Oh, fate, it tempts me, and then it turns away. When I was young, so many people told me I was wrong. When I was young, so many people told me I was dumb. Truth is, I spent my whole life trying to prove them wrong, but in the end they won. Show me now I don't know where I'm going, and I don't know where I'll be gone. I gotta find some way of leaving this cycle that goes on and on. There's gotta be some solution for the forlorn. Now I know I feel guilty, 'cause I've really got nothing to complain about. I said I should be feeling guilty, 'cause there's nothing I should be complaining about. I'm privileged and I'm healthy, so I should just shut my mouth. I bet tomorrow I'll feel better, because tonight I sing this song. I'll get myself out of bed, and I'll put the world on my shoulder, and I'll carry on. And I'll be thankful that there's someone who missed me if I were gone.
Yeah, I hardly remember doing that one. I was obviously in a bad mood that day. Some of the lyrics weren't that bad. Might have to think about that hardcore blues song for the future. Anyway,
Hello, Dino.
yeah, hello. How? So let's see where this went wrong. Or maybe I lost a bit because let's put the dump in there. So I looked at the bit 0, bit 1, bit 0, there's the first. Right, byte starts at 59114. I think the problem is that when I skip the bit, I'm probably skipping too much. Is my best guess as to what's going wrong. I mean, what else can it be? So I need to, it's this skip bit. And this is the bit samples, and I say there's 80. Let's see if that is correct. I mean, for example, in here, if I skip for the algorithm, I go find the next long cycle. It does it here, there, probably. And then what I need to do is skip the start bit. There's 1, 2, 3, 4, 5, 6, 7, 8 of these. If I take it from the upwards cross, just to count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, it's more like 78, not 80, but could that really be it? I doubt it. It could be that I need to move back a little bit and yeah, well, it's edge cases everywhere. This is an edge case nightmare. No, it's still missing a bit. But you see, that's the weird thing, is that the byte starts at 59914, the first bit that it found. Oh, it looks like it's missed as the first bit. I think it just misses the first bit because I made a silly mistake. I skip a bit. Why does it say byte starts, find the next long cycle, and then I skip a bit. Actually, it doesn't make sense. It's better just to say the previous down cross is the byte start. The length was that's right. It says the byte starts at 59914, but the first bit. Okay, and then it skips a bit, so that would be skipping around 80. But the first bit that it found started at 60,010. So that's the 6010 was the previous down cross. And I check the length. So this is the first cycle of the bit. And it started at 60,010. However, the byte allegedly start at 59914. It should be about 80 long. It looks like there's a cycle missing. So oh. Yeah. When I skip. But I need to subtract. Bit start is the sample count. It's actually not the sample count. It's the previous fine. Next down cross is yeah. Skip bit. I think the bit start should be the previous down cross. Didn't make any difference. 1, 2, 3, 4, 5, 6, 7. Oh, it did. It didn't change that, but here we have 1, 2, 3, 4, 5, 6, 7, 8, and then oh, and then there was a 1. 8 bits and then a 1, and then there was another 1. You see, and that's disappointing that there are 2 1s, because there should always be a stop bit followed by a start bit. So there should always be a 1 0. Oh, right, yeah, because I'm not skipping start bits. Ugh. One, 2, 3, 4, 5, 6, 7, 8, 1, 1. How can that be? Well, I suppose what I could do is just write it out. Well, is this crossover? Let's look at the positions of the things. So I have 14, I add 80, I end up with 94. And this bit 73. That was a 20. Cycle on there. Hey Mike, how you doing? Hello to Greece. Welcome. I think what I'm going to try to do is to print each one of these sort of micro bits or whatever. Well, there's the sample and there's a cycle. Tough visualizing it. How do I visualize this? All right, well, I'm going to do some things to help, because part of the problem here, a bit of DevOps, because part of the problem here is that there's too much data coming through, so I need to turn on and off the log. So I'll do putting a bool here, logging equal false, which is great, and then and just make everything public. Flipping heck. While I debug this. So after finding the next cycle, I do logging equal true. So I turn logging on. It's good to have someone someone saying hi who's like a little closer to home, you know, other than America and Australia. So where the byte starts, we can see here we have stuff going on. What's it looking for? So maybe I should say what's going on. So we need to, when we skip a bit, I can say print. I can print where we're skipping. Skipping. Bit start equal %d. We can see how many. Yeah, okay. Let's print that. Yeah, I've got some ideas here. Bit start equal bit start. So we can see where the bit start is. And then I can also have a counter in here, which is 0. And then find the next down cross, count plus plus. And then we can print found %d down crosses. And we'll see if that shines a light on the problem. I wasn't saying I wasn't criticising Australia. Little factoid, do you know that I once interviewed for a job in New Zealand? I didn't get the job, and that probably was for the best. It wasn't a studio, it was a school. It was a game school, but I can't even remember the name of it. It was in Auckland, I think. Yeah, but the problem, I was concerned about the fact that the school had been bought out by a corporation, and I was thinking, there was not. I tested them to see how flexible they would be, to get a feel for, you know. And obviously they probably felt I was pushing it. But one of the problems was that, I was moving from, I had 12 weeks holiday as a teacher, though I couldn't choose where those holidays would be. It was a good amount of holiday time. And I was concerned that if I could move to Australia to work New Zealand to work at another school where their attitude was very different, and I wanted to be able to go visit my parents. So it found 4 down crosses. And that's exactly how many I would expect to see. As it skipped a bit. 4 down crosses. Then it looks for the first bit. Once it skip it, let me print another. So I know that there was a down. I'm looking for the next down cross. and that happened here, and that was 20 cycles from 6010. That's correct. So at 20 cycles, that is one, which is fine, and then it wants to skip. And it only found 3 down crosses because it's skipping from it found 3 more because 1 was already detected, right? So in fact, actually at that point, that's all making good sense. Then and the bit was 0, then it's checking a bit. And now this is a short one, so it's a 1. Then it needs to skip. It found 7 down crosses, which is absolutely correct because there should be 8, but 1 was consumed checking the bit, and the bit was a 1. And this is a 0. Okay. And then it checks, and how many down crosses do we have? 3 down crosses again, bit 0, checking bit. It's a 0 again. 3 down crosses, checking bit. It's a 0. Found 3 down crosses, checking bit. It's a 0. Found 3. It's a 0. Found 3. It's a 0. Found 3. Now here's checking a bit, and it found a bit of 14. It's one of those half and half because it's a bit messy when it switches between the two, because it should be either about 10 or, yeah, it's right in the middle, so I suspect then it found 5 down crosses, so that's what it is. The good news, it's working basically, but I'd have to cope with this noisy this noise on the crosses when it crosses over between one and the other. Sometimes it doesn't do it so cleanly. So what I'll do is turn the logging off, the detailed logging off. I don't need it. So 4 down crosses, then there was 3, then there was 7, then there was 3, then there was 7, then there was 3, then there was 7, then there was 5. And that's wrong. And you can see there where we're checking, it was a 14. How do I handle this? I have to resync it. It can't be a 14. It has to be either a 10 or a... Well... I have to recalibrate it according to what it should be. Yeah, all right. When I check the bit, at the moment I check until I'm looking for the end of the to keep it in sync. I'm looking for the end of for a down cross that signifies the end of the byte, end of the bit. I mean, the problem is that sometimes that doesn't work, as is this case, because they've got a confusion between two cycles of different frequencies. So what has to happen is that if this is outside of of a certain window, then I have to predict it. I need to see that this is in fact a bad case or an outlier. The way that works then is to go, when I do the skip bit, if I found I can't really rely on that. I need to yes, because I know what the bit start was. I know what the bit start was. What I can say is how long the bit was measured to be. And that will be from the sample count minus bit start. And then I can do a little bit of an adjustment. Because what I can't do is I can't just start at the beginning and assume that the timing of everything is on a grid, because the sample rate is going, the samples are going to shift in their position, and also it's coming from a different clock. I imagine there isn't going to be much of a variance, but I mean, you know, unless I calibrate it to this particular system 1, and I want to use this for other, I want to use it on the Acorn Atom as well, you know. So so let's try this. Oh, there it is, we can see it here. So the bit was measured to be 96. Really, they should be measured to be 80, so that one is 16 over. This is 82. Well, I don't know. 82, 90, 91, 96, 96, 96, 96, 82, 84, 96, 96, 82, 81. All right. Let's see what happened with the bad case, which is here. Bit measured to be 96, and then there was 82. There's far too much variance. I mean, that doesn't make any sense at all. There's so much variance. It shouldn't be. Small amount of variance, yes, but this is huge. It's a variant of over the size of a cycle. I mean, the bit measured to be sample count less than bit samples. Less than bit samples. Wow. I think it's because, well, okay, so the first thing is that I am really on an edge case. What I need to do is do bit samples minus, say, threshold divided by 2, I think. So that I'm, because it could be that I'm losing out where I'm, it's sort of biased towards once. Oh, look at this. Oh, it looked really consistent for a bit there. 77, 76, 77, 76, 77. That was a lot more consistent. Then there was this big one. Oh! Well, the bit was measured to be 77. Cycles. Checking bit. This is our 0 bit. It found only 2 down crosses. Minus threshold divided by 2. The threshold is 15, so that would shift it by 7 cycles. Yeah, I think it's too, it's actually too much. Maybe let's just try, well, threshold divided by 4. I see, it should have found 3 down crosses and only found 2. huge variation again. Although it seems like, oh, consistent, so a little bit bigger, bang, that's a lot bigger. That's because let's try another method. Instead of doing that, we count how many down crosses we need. Okay, find the next down cross. Another count. Bit down crosses. Now this is how many have been found in this, down crosses have been found in the current bit. So bit down crosses equal 1 in this case. This is I know where the down cross, by the time I found it, I've actually consumed the first cycle, right? So that needs to be set to 1 at that point. When skipping a bit, I can come to that in a minute. When reading a bit, I need to change my chair, I think. Right. I can't stay more than a certain amount of time in the reading chair. I have one place I worked, I tried to get a standing desk. I never got the standing desk. I can recommend standing desks for VR work. Had one at a previous place. Standing desks are very they're good, but actually I find that kneeling chair is very good. You get a bit of context of what's going on, because otherwise, yeah, that was the idea of that. Well, the thing is that when you're using VR, especially if you're tethered, if you have a tethered headset, it's actually quite complicated to try and avoid getting the headset tangled up in things. I had it would get tangled in my chair, it would get tangled. I would, go under the chair, and I put tape on my chair to stop it getting tangled in the armrest of the chair. And the thing is that then if you put your computer on the desk and it comes up, then the cables go up in the air. so they're not on the ground. And they're on the ground, they get tangled in things, you know. You probably thought I was crazy. I mean, it's like I've put this tape on my chair because I'm that kind of person who's, there's a problem, I solved the damn problem. You get a problem, you solve the problem. The problem is that my headset cable keeps tangling in my chair. Solution: get tape and put the tape on the chair to prevent, that stops the thing getting tangled up. It's not a game. It's important. Other people seem to not have this problem of it getting forever tangled in their chair, but or maybe it does. I don't know, and they just sort of live with it. But I kind of like it, find it irritating. So. You know, but people can think you're a bit weird sometimes when you're doing things like that. I mean, even to the extent of the vertical monitor. You know, if you're a programmer, have a vertical monitor to be able to see your code is actually really useful, right? But I've worked in places where I was the only person who had the monitor like that. It's like, so, you know, maybe I should learn to fit in, you know. It's like, no. Yes, it does help. So what was I doing? Assuming we are at the start of a bit, and then I find the next, I lost track of what I was doing. What was the last thing I edited? The bit down crosses, that was it. So when I read a bit, I find the next down cross and I can see which. Alright, so what I will do is I will say bool bit equals length less than threshold, skip bit. If the bit skip cycles and then check the bit value, and if the bit value is 1, then I need to skip 7, otherwise I need to skip 3 cycles, and then I return the bit, either 1 or 0. So if I'm skipping the, so this would be skip cycles instead of skip bit. Try a different approach here. Skip cycles, int count, because that didn't work. For int I equals 0, I less than count I plus plus, and find next down cross. Bit start equals previous. Do I even need the bit start anymore? What was it used for? I'm not even using it anymore. Good, let's get rid of it. I don't need it there. So what we do is we see if the bit is being measured to be a 1, it means it's a high frequency, double the frequency, and I've consumed one of the cycles, and there should be 8 cycles in total. Now, the point is though, I'm going to have to deal with some edge cases anyway, but this should at least be a lot more consistent, I hope. We'll see. Well, you know, I was doing the skip the bit, but I don't skip the bit anymore. I'm just going to find first 0 bit and skip. Just say what it does. Oh, flippin' heck. It basically does everything that I do in here until eventually I find it, and then I just need to do skip cycles, and I know it's the first 0 bit. I need to skip 3 cycles, and then is there anything using find next long cycle? I did the wrong, I modified the wrong function. It's this one. Right, find first 0 bit and skip. We find this, we do all of this, we go down to here, bit down crosses. That's a bad idea as well. That's getting far too complicated. Let's get rid of that. No, okay. And we could do skip cycles, and we have to do a count for skipping cycles of 3. Skip 3 cycles. Let's try this. So there we go, checking the bit. It was a 0 bit and then a 1 bit and a 1 bit. Seriously? Ah. there was right. I really get into trouble. Let's turn that logging on. Oh dear, I knew this was not going to be easy. Suspect my approach is not the best, but pick one. So I'm checking the bit, and I've checked this and seen that there was 19 till the next up, which was fine, and it carries on from here. You can see that it's, if this is positive and that's negative, like here, to so let's I don't know what I'm going to do just to help. Is mark where I print this out, is print an exclamation mark if the previous sample is greater than 0 and current sample is less than or equal to 0, and a question mark if that's true. Put an exclamation mark on that line. Oh, why don't you like? Right. So there it is. That's a 0 crossing downwards. So once the bit was found, it had to skip the bit. Who's checking the bit? Oh, right, okay. That's after the thing was found. So it has to scan forward to the next one, which was there, and that was 19 samples, which is corresponds to a 0. Now it needs to go and find the end of this which would be 1, 2, 3. The bit was 0. And we check the next bit. Now, we're expecting a 1, and that is what I see. I see a 1, which is great. And then it needs to check 1, 2, 3, 4, 5, 6, 7. Bit 1, checking bit. And see, and that's the one that now thinks it was a 1. And then of course everything goes out. Because for some reason, and I'm looking at this, it's perfectly correct. It takes 14 cycles because it's actually 1.5. So it should it's actually it should be a 0. But it's longer than anticipated. I think that I just need to set the threshold. Right. When running through the finding the next cross, I need to be smarter. I could put it actually in here. When I find the next cross, I can look at the tolerances, and then I can flag when there's one that's questionable. Then it needs to fill in the gap itself, or needs to correct it. So if I get the next sample and then I find that, right, there's the crossover, and then it just sort of says, hey, we're done. But what I can actually do is check the length here. The length is equal the minus the previous. Down cross. And actually, if I print these out, then I can see each down. So what I'm doing now is looking at every time I look at a cycle, I'm examining its length. The cycles need to be either one or another of a length. If it's in the middle, it has to correct for that, and that is because there's a glitch in where it crosses over between the two frequencies. So put that with the length. Right, so what we see then is down cross found at sample 16, length 9. 9, 10, 9, 10, 9, 10, 9, 10. This is nice and tight. There's no problems with these. 9 or 10, 9 or 10. Happy, happy, happy. Yeah, I think this is going to be the correct approach. Now, I've got too many of these in the, when it's, I just say if logging there we are, and then we run this. And there was one, and it's a length 19, and that's okay, it's double. 9 or 10 or 19 or 20. This is one length 20, and this length 19, and then there's this one which is 15, and that's off. And what it is a half. It's like 1.5. You can see it sort of here. In fact, it's exactly this type of thing. The ends of this is 2 0 bits following each other. 1, 2, 3, 4, and 1, 2, 3, 4. Oh, maybe it isn't this one. So look, when it's a 1 bit, I know I've read a bit, I need to read 3 more. So here was the first, which was length 20, spot on. The second, which length 19, spot on. But the last one was short. So what do I do? I ignore it. Oh, okay. It's halfway between the two. Let's look, let's inspect this. This is hard. Let's look hypothetically at this one. What would happen if that didn't cross the line? I would look for what a crossing, and the crossing would be very long at the end. Oh, hi there, Mark. How you doing? Good to see you. This is the project associated with this thing that I want to get the cassette port to connect to the PC, but I want to do it dynamically. So what I'm actually doing is this is frequency shift key data storage on cassette tape. That's exactly the vibe I was going for, mate. I gotta see, that was exactly the vibe. That's it. All aboard. You got your ticket? Get your ticket. It's a lottery. Get your ticket. So what I'm trying to do at the moment is reliably read this frequency shift keying and turn it into hex. That's basically it. But I'm trying to figure out a completely reliable way of reading these bits, and Part of the thing is that these bits were read by, not by software, but by hardware. The cassette port of this thing actually just sends, when it switches from one frequency to the other, and it just sends that information in. But I'm trying to emulate the hardware. That's as hard as what I'm trying to do. Well, it is what I'm trying to do. Hal, play Mark theme. I would have been very impressed, Hal, if you got that, because you've been so quiet, hadn't you? Let's try it again. Well, hello, Hal. Yes, there's still this thing. So what we have to do is we have to wake Hal up. Hello, Hal. Yoo-hoo. Put it there. Hello, Hal.
Hello, Dino.
Hal, play Mark theme. Oh, I'm back. Yeah. So, what to do when I get a cycle that's a half cycle? I need to... Yeah, because I've got something's gone down. The problem is I'm in the middle of two, so it's like exactly halfway in between, which actually makes sense that it's halfway in between, but I'm trying to figure out what should I assume. In this case, we're going from... Right, let's look at the transition then. So I found a 0 bit. I look, right, from the beginning, I found a 0 bit, and it was length 19. Because of the length 19, it was a 0 bit. Okay. it went to the end of that, of the cycles for that byte, and it goes to the next one and it was the same, and the next one and it was the same. But this last one, oh right, no, because there it read the bit, okay, and now it's skipping. So this is a 0 bit, and I know that after this there is a 1 bit. So this transition that happened here is between a 0 and a 1. So that would be like this transition. So well, what we've got is this. It should have been longer. Because I was expecting, right, there should be 1, 2, 3, and the last one is short. So it needs to be rounded up, because these, whatever happens, these bits should be always the same length. So what I think I need to do is, if the length is less than 19, for int I equals length I less than 19 I plus plus get next sample. So what I'm doing here is, if fallen short, correct it, and so that is just going to shift it until it's the number of cycles that it should be. We'll see. So we go back to the beginning, and so the first one, 19, then 20, that's the second cycle, the third cycle, 19, and it corrected it, and it's still 19, so hang on. So that's a 0 bit, and that means it was registered to 0. 1, 2, 3, 4. It always says length 19. Why? Oh. No. That's trying to force them all to be long. It's if length is greater than 11, and less than, and length is less than, if length is greater than 11 and length is less than 18, so if it's in a kind of somewhere in this limbo land, then it's going to assume, this is assuming that it should round up. Let's try that. Down cross found at sample length 19 to 20 to 19 to 19. So that's 4, right? 1, 1, 2, 3, 4, and now the next one, it found a short one. This is a 1 bit. Okay. 2, 3, 4, 5, 6, 7, 8. So it's arrived to the end of the bit. It's checked and it says it was a 1. It's checking a bit and it found that it was length 19. It was 14. But it expanded it to 19. 19, 19, 19. Why didn't it say bit 0? Bit 1. Oh, because it has to say at the end when we get to the end. Oh, and it says bit 1 again. The decision on which kind of bit it is, where was that made? Read bit, it checks for it to be the length less than the threshold. So what I need to do is get the next sample and then current down cross afterwards equals right. Let's try that, because what I was doing was not updating the correction, so it was reading the wrong time period for the particular bit. So let's try again from the beginning. Let's okay, 90. I'm going to get rid of all the I'm going to turn off all that detailed logging. It's just like too much spat. There we are. So get a summary. So a down cross was found. We have a group of 4 downward crossings. They were all measured at 19, and it says that's a 0 bit. Then it was checking. So this if first part was a first cycle of the next bit was short, which means it is a 1 bit, 1, 2, 3, 4, 5, 6, 7, 8 cycles consumed, the bit was 1. And now it looks like there's another bit which is 1. It doesn't make, it shouldn't, it should be 0. So that's confusing. Oh man. Right, so down cross found at sample 59997. Yeah, okay. I can only assume geez, I'm not making much progress with this, am I? I'm going to have to change my approach because this is just insane. I can't. It's too difficult to debug. So the alternative approach is to do the following. To do a first pass that converts the frequencies to zeros and ones. This is more like the way the hardware does it. What do I do? Where do I put that? Put that in an array. I'm going to just an on-off array. Oh, I don't do an array. I really want to do it in an array. Right, how big would the array need to be? If I wanted to be able to calculate, to store, say, 65536 bytes of memory, if I multiply it by 10, then I end up with 655,360 bits. And but I'm doing this on a cycle by cycle basis. If I emulate, if I do it in a similar way to the hardware, I need to multiply this by 4. I need to be able to have a 2.6 megabyte array. Oh, it's not too bad. And that I only need a tiny fraction of that for the moment. So this is good enough for now. So what I'm going to do is put the maximum storage capacity bit stream size is going to equal, for now, 1024 bytes multiplied by 10, that's the number of bits, multiplied by 4. So right, and then I'll need to do is on the stream stream index equals 0, and so the way this would work is make bit stream and actually, you know what, so make bit stream. What this is going to do, because it's also going to just encode that it's really going to be inefficient. It's just going to encode even the leader. I'm basically doing a dumb reinterpretation of the frequencies to just create that as a stream of ones and zeros. Yeah, I'm making really good progress. Yeah. Make a bit stream. So the way that would work is there I have an index. You know, I was just doing that because I just sort of hate the idea of oh, all right, it's actually, I'll use a vector then. It's a vector of booleans is something that just makes me feel weird, you know. It's like let's make it a vector of ints instead. All right, we'll do a vector of bools. All right, okay, a vector. I don't know why. It's irrational. I need to snap out of it. std vector. Jeez. std vector bool. Stream. I'm just going to call it stream, right? So there, I did it. Make bit stream. So to make the bit stream, I'm going to while, well, or for, like so. I'm going to do find next down cross. Let's just, right, just do an initial one. Then we'll do find next down cross, and then after doing that, then we'll see what the gap is. And this is none of this horrible correction stuff which just confused matters even more. Right, so that's a simple one. You find it and you measure it. So it's a list of the gaps for each one. And it's going to, and then I clean that up or something. I don't know. Make bit stream. So we've got that length there, and we say if length is less than, oh, actually, stream dot, no, this is not C sharp, push back length is less than threshold, in which case if the length is less than the threshold, then it's a true thing. And then I'm going to go just down here and do, and just comment out all of this stuff. And the only thing we're going to do is get that going. Make bit stream. So I start dealing with bit stream size. No, I don't need that anymore. Next. Oh, that was the only problem, right? And then after the creation of the stream, I have something that I can then analyze. And but for now, I'm going to just get it to print the whole stream. Print %60% D \n sample count length less than threshold 1 0. We'll try that. Oh, so it doesn't print. I missed out the F. Try that again. And what do we have? A lot of numbers. And at some point they become zeros. As you can see, it's around 60,000. So this should look like that. there was all ones, and then we had some zeros, and we had 1, 2, 3, 4, 5, 6, 7, 8. There were 2 0 bits. That was a start bit and then a 0 bit. Then we had 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. Well, in fact, there needs to be 8. So then we have then a bunch of zeros and then a 1. So actually, that looks correct. Then there's a whole bunch of 1s, which is that bit there, and then it comes off. Right. Having got to that format, then I don't need to worry about. I mean, basically, if anything, it just makes it easier to debug. So, having made the bit stream, we need to then analyze the bit stream. I need to find the start of the bit stream, the start of the recording, which begins on the first 0. So I need to just scan through this to get the first 0 is the, and actually from this, probably this is going to be a lot easier to do this way. Extract bits. And so first thing we're going to need to do is scan for first 0. Now it's so much easier to do it this way. But the disadvantage is I'm allocating memory. So what I was trying to do is just do it on the fly, so I didn't have to allocate memory. But now I'm allocating memory, I'm putting it in a buffer. I was trying not to do it that way, but all right. Make it work first, optimize it later. So first step is to scan. First step is to scan for the 0, and what I'll do is I'll set index equals 0. I'll forget comments for now. 4. It's obvious, isn't it? 4. Index is while. Stream index, while that is true, index plus plus, and then we scan through all of that, and then boom, I should end up with actually I do need a comment there. First 0 bit, find it. So we find the first 0 bit, and then from there onwards, everything needs to be roughly going in the form of a grid. Yeah, okay, but I can correct timings as I go. Yeah, I can start at the beginning at this point and say, what do I have? I have a 0. How long is it for? Right. How many? It's useful to have a function. You see, this is a pain. Let's just do it. So I find the first 0 bit, and then we want to see how long are the 0 bits. So we do while zeros equal 0, cheesy, but right. So how long are this? That will give me how many 0 bits there are. Let's just do a print at this point. No, I'm not even. I can use the debugger actually. Let's just do exit 0 here and put a breakpoint there. I keep forgetting that I'm actually just use the debugger here. No, it doesn't like that. See, that's why I hate debuggers. It's because it isn't called, and you know, it's like they just terribly confusing. Moved it. No warning. It's because it's not calling it. Let's try again. It did it. Jeez. Extract bits. It's called. Let's put a breakpoint here. No, make bit stream. Put a breakpoint there. It's just like. Okay. And it just quits. How great is that? I mean, what? See, I'd be better off using print statements. Now I'm trying to understand why is the debugger doing this. It quits inside of. That would suggest it quits inside of. Was there any error message? Oh, unexpected end of file. Oh dear. Okay, yeah, that makes sense. So this was. Oh, or if it's on there. I was saying get next sample. So let's find next cross. Yeah, of course, now, because I'm putting it in a buffer. If not, get sample here. Just do break out of the for loop if this returns false, which I'm going to make it return false when that happens. But if I get to the end of the function, I will return true. Okay, so let's see. So not sure exactly what happened there. it's stuck in an infinite loop because return false, otherwise return true. We have find next down cross. While find next down cross. Right, and how it might, oh, what's wrong now? Right, so I'm missing semicolon. Must return a value. Return true, okay. Right, run this. Great. It did that, and then we run extract bits. I go in, goes here, find first 0 bit. All right, until we get to that, go. It found it, presumably. Actually, I just wanted the breakpoint here. And so, okay, boom. And now, what is zeros? It found. That's because I needed to reverse the sense of it. Let's try again. Alright. On here, how many zeros? 8. And so that is actually 2 bits worth. So I need to then write out the bits for a 0, and I know there were exactly 8, so I know there are exactly 2 0 bits. So what I could do is I don't actually need to do that. I can probably put this into a loop. I can just analyze it. So we with a while loop. While index is less than stream dot size, we can look at that bit. I can say I have a 1 bit. 0 bit. Chain equals 0. Index current. Make this a Boolean. The sense of whether we're processing 1 bits or 0 bits. Actually, let's call this 1. If 1, else. So if we're processing 0 bits, then we're here. When did I set that? No, let's use a three-way. We'll call it bit. And initialize it to -1. If bit is less than 0, there is no bit currently set. If that's the case, then we look at the current, well, let's get the current one. What's the current state, which is the bool. Current equals stream index. If bit is less than 0, it means that no bit is, nothing is set. Not set yet. So I will then set the bit I don't like that. Change my mind. False, valid. If not valid. If not valid, then bit equals current. And valid equals true. And chain equals 0. One technically, because actually that's better. Right, so if the chain is less than 1, it means that, well, we don't have a chain of bits, so we'll set the bit as the current chain that we're doing, and we'll set the chain to 1. Otherwise, if the chain is 1 or more, then we need to check to see whether we are processing 1 or 0 bits. So if bit, we are processing a 1 bit or a 0 bit. So if we're processing a 0 bit, which is the one that we'll be processing first, we expect to see 4 bits. Well, let's see how many we've got. How many do we know? It's kind of interesting. We just have to count them. So if we do the chain plus plus, if the chain is greater than or equal, if the chain is equal 4, then we've consumed the bit print percent D and, well, we actually know here there's nothing to just print 1. And then at this point we say the chain is back to 0 And we're done. And it's a 0, not a 1, right? If we go back to this one here, we can do if the chain plus plus, if it's equal 8, this will break down because sometimes it'll be 7, but we can fuzzy that one up later. That basically goes, if it's a 1, we expect to see 8 ones. That we also need to get the current. Well, I've got the current, and we also need to increase the index. So if we are currently processing true bits, 1 bits, we actually need to look at the current. This actually becomes a little if tree here. If the current is also right, if the bit is set, it means that we're currently processing a 1 bit. We check if the current one that we are reading will be the new one in this pass, because at the end here there will be an index we need to increment the index, but I'll do that in a minute. So if the bit we're processing a 1 bit, if the current bit that we're just reading is also a 1, then we increase the length of the chain, like a combo chain, you know. So it's because that's cool, right? The chain of continuous ones are increased, and if we have reached 8, then we are confirmed that we have a 1, and we are finished with this bit, and the chain goes back to 0. And index, the index going, actually I'll put this, I'll put this on the while just before the thing here, like so. So what we have is, when this first starts off, we know that we're going to have a 0 bit, because we looked for a 0 bit, and it's going to take that 0 bit in here, and it's going to say the chain hasn't been set. It's going to clear this bit because that was a false bit, right? 0. And it says now the chain is length 1, and it will come down, it will increment the index, come back to here, get the next one. So we fetch the next one, and it will say, was chain less than 1? No, it isn't. We do have a chain this time, so it comes down to here, and it will say, is the bit set? And it will say, no, it isn't. We are currently constructing a 0 bit. So that will come into this part where we need to check if not current, because we are checking for a clear bit. If then we need to increase the chain. If the chain reaches a size of 4, then we have finished doing our 0 bit. Now the interesting thing is what happens if we get these other conditions. So that's if it changes before we reach to the number of right. We were waiting for 8, and we only get 7 before it changes, and that means that there was a problem, and I know those are going to happen. I'm pretty sure those are going to happen, and so then we'll need to deal with that case. Yes, I want to stop debugging. Errors. What have we got? Signs, a warning, signed, unsigned. Print F. Okay, and then we run this. You got to the end without generating a single error, and that doesn't seem plausible. I think basically nothing worked. We are also printing out the stream when it was made on here. Make bit stream. I don't need that. I want to print only on extracting the bits. And let's set a breakpoint in here so we can trace the code here. Thank you. So we can trace the code. And there we go. Right. Ah, damn. All right, well, let's get down to there, set a breakpoint there, and we'll see. Right, so he does this, right? Okay, we don't have a chain, and then we increment the index, and bit at the moment is false. And then we go, all right, and a bit, it's false, and yes, and the chain goes up, and the chain is now equal to increment the index, back we go to here. Okay, current, again same thing, and now it's 3, and then it comes again 4, and it should have printed 0. All right, well, that suggests that in fact something is working. So right, we ended up with a 0 bit. Well, that's the start bit. We ended up with a 0 bit. That's the first 0 bit. We ended up with a 1 bit, which is this one here. Then we ended up with an error. So error 1, error 2, I don't know. Actually, technically, that's error 0, and that's error 1. Okay, so then we can try again. And it's error 1. Now, that means that it changed to a 0 before we got to see what the count is here on the chain. How long a chain did we get? So I think this is good progress. I don't think I'm going to have to stop very soon, so I don't think I'm going to be able to finish getting this to work, but I'm going to be in a better position than I was. But let's see, we're on here, blah 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 blah, error 1. Oh, now that's a bug, because surely, so after having done a 1, I set the chain to 0. Alright, let's put a breakpoint when it prints the 1, and then I can trace that. So here we go, on there, and we go right, it goes down to there, up to there, back to there, takes that current. The current value is true. So it means that, okay, and then the current value is probably false. False. So what happened is the error was due to the fact that there was in fact 9 of these bits, not 8. So I guess, so then it thought there was a new 1 bit coming, and in fact it was just the end of the... So one way of figuring that out is what if the chain yeah, how if the chain is trying to reach 9, I don't know. If it's trying to reach 9, how do we tell? Well, what I'll do is, instead of saying jeez. If you continue running this until you've had 8, you know for sure that you've got a... Yeah, how do I know? If it could be another 1 bit coming. I don't know. Which is it? You see? I need to... I can't discard it because... Or I could do an average of the bits. Oh man. If the chain of 8 has been made and then we have 1 more come along, how do I know to discard it or not? You see, it's really annoying. It's not helped by the fact that the way this is working is that it sends it creates 2 entries for a 1 bit. Two cycles for a 1 bit and 1 cycle for a 0 bit. And it goes around and it says, oh, yes. I know I had the 1 bit. I've got the 1 bit. And the next one comes along, it says, what is it? Well, actually, what I can do is say the error that arose was because it came and thought it was going to be it was processing a 1 bit, but it then turned out it's not processing a 1 bit, it's really processing a 0 bit. What I need to do is see how long the chain is at this point. If the chain is less than 4, actually that's too much. If the chain is less than 2, it's noise. So change to 0 bit. So what happens then is I reset, yes, else I print an error. So now I'm going to create a bit of fuzziness, because what basically is happening is it thought it was processing a 1 bit, but now the bit is going to be cleared. It's going to be, bit is now false, and the chain is now 1 because we've just processed a, we've just processed a 0 bit, and that's it. So what it does is it just ignores the extra bit. Oh, maybe, let's see. Oh, it got further. 0, 0. Ho, 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 ho. 0, 0, 1. And 1, 2, 3, 4, 5, 6, 7, 8 bits. And then there's a 1, which is this one. And then there was 1, 2, 3, 4, 5 zeros. It's getting closer. It is 1, 2, 3, 1, 2, 3, 4, 5. Those are 5 bits of 0, and this is supposed to be a 1, but we've actually got an error, and this one's error 1, error 0. So this is going the other way. And so I need to set up a similar thing on the other side. If chain is less than 2, so we allow a little bit of leeway, fuzziness in there, else I generate an error. And in here we do the opposite. We switch from the sense from false to true, and we set the chain equal 1. So it's ignoring the bad guy. Let's have a look at what we get now. So yes, we got an error again, but I think it got a bit further. 1, 2, 3, 4, 5, and then there was the 1, and then there's 1, 2, 3 and a 1, and so we got an error again. Now this case, error 1, but this is with 7. So in this case, with 7, it wanted 8. It changed back to this is the other case where it actually was short. There were too few. One was too many, and this is too few. We had 7, a chain of 7 ones in a row, and then it didn't find the 8th. So if chain is greater than 6, else, like this, and this is noise changed to 0. No, this is noise enforce 1 bit. So to enforce the 1 bit, we basically say print 1 and reset. The chain is now 0. No, not quite. The chain is now 1. And the bit sense is false. So we actually print 1 because it's been corrected, and then I think connection went down, should be back. So error 02. Now what's error 02? So this is down here, and we had a two. So this is a bigger glitch. It's a bigger glitch because error 02. We had a chain of 2 zeros, and then it wanted to switch it, and I'm allowing it. It's basically saying, yeah, well, these zeros are nah, I don't like that. The error is a bigger error that occurred, but this is on the chain, the end of quite a few 0 bits. Yeah. I could just say less than 3, which takes it up to halfway, and similarly on here less than 5. It processed with no errors. I mean, this is a bit hacky. I don't know whether to believe this or not, but the test would be to go through here, and we should see is that after an initial few bytes, it could be right, you know, but I'm gonna have to call it a night because I've got to go to bed. But that's a step forward. It's beginning to make some kind of sense. I'm still not 100% happy that the algorithm is truly valid. But it's going to be fun. It's always about fun, isn't it? Have a good night, everybody. I'm off. Thanks for watching.
In the beginning was the Word. And the Word was God. I was walking along and right by the stream searching. I felt like a 2-year-old urchin. Was thinking about the sun somewhere behind the clouds.
and the trees, they all agreed with that chattering sound. I went for the stars, but I could not see any, nor the sky above, nor eternity. There were no words to spoil or taint the scene. No black, no white, no grey, nothing to be. So tell me, did he really know what he was making? And does he already know the ending? If God had a river of his own, did he learn to let go? Let it carry him down to where he needed to go. Was there anyone looking after the place where he would be? Thereafter I want to know about God and the river. Makes no sense, can be no pretense. If you look at us, we're all like little children playing in the playground, but not so nicely. If God is our parent, then where the hell is he or she? Tell me, did she really know what she was making? And does she already know the ending?
Obviously, that forces us now to fade it out by then.